Good morning, the professor and gentlemen. My name is 万峻from our Department of Electrical Energy at Ishu University. Today, I'm going to present our study topic, Development of Zero Photovoltaic Power Condition System based on CN and Transformer with Real-Time MBLD Interface. Thank you. In this study, we developed a zero power condition, zero power monitoring and forecasting system. This system combines IoT technology, MBLD communication, and a CN transformer deep learning model. The main goal is to monitor zero power generation in real time and predict future photovoltaic power more accurately. The presentation includes these parts. First, I will introduce the background and research problem. Second, I will explain the monitoring system architecture. 3, I will introduce the MQTT and MBLD interface. Fourth, I will explain CN transformer forecasting model. Then, I will show a result. Finally, I will give a conclusion. In recent years, renewable energy has become very important. It's very important. Zero power generation is one of the most useful renewable energy technologies. However, zero power generation is not always stable. It's easily affected by weather conditions, such as sunlight, temperature, clouds, humidity, and pressure. Because of this, photovoltaic power generation has an intermediate and function nature. It's very challenging to power detection and energy management. To solve this problem, the study combined MBLD real-time monitoring and CN transformer forecasting model. MBLD is used to transmit real-time data, and the CN transformer model is used to predict future zero power generation. The slide shows the structure of a real-time monitoring system. The system is built for zero panel installed on the rooftop of the technology building at Ishu University. First, the inverter collects important electrical information such as voltage, current, frequency, power, and accumulated energy. The system uses ICPMMT 4 and 5 communication to read data from an inverter. An IS4 and 5 to TTL module is used to connect inverter and ESP32. The ESP32 is core controller. It receives power data, processes the data, and sends data to the MBLD module. After that, the MBLD module transmits the data to cloud platform. User can check the zero power data through a website interface. Its architecture is low-cost, easy to deploy, and suitable for long-term monitoring. This slide shows the MQTT communication structure and a real-time monitoring interface. MQTT is lightweight communication protocol. It's very suitable for IoT application because it's low bandwidth and transmits data quickly. The MQTT system includes 3 main rules: power ratio, blocks, and subscriber. In this study, zero monitoring device works as power ratio. This power ratio zero power data to the MQTT block. The block receives forward the data. The web interface works as a subscriber and receives real-time zero power information. Compared with traditional HTTP communication, MQTT is more efficient for the IoT system. It can reduce network loading and improve real-time performance. The monitoring interface can show current power generation data, display historical data, and allow users to download CSV files. Before training the forecasting model, data processing is very important. In this study, the input data include two parts. The first part is historical photovoltaic power generation data. The second part is meteorological data. The meteorological data includes several reduced in temperature, wind condition, the direction, relative humidity, and the pressure. Because raw data may contain missing value or abnormal values, we clean the data first. Missing value and audit are current to reduce noise. After that, normalization is applied. This can reduce the affected or different physical units and make model training more stable. Finally, the data test divides into 17% train data, 15% validation data, and 15% test data. The slide shows the CN transformer hybrid model architecture. We use hybrid model because photovoltaic power data has both short-term changes and long-term time relationship. The first part of model is CNN. CNN is used to extract the local factor from the input data. For example, it can learn short-term change in the zero power and weather conditions. After CNN feature instructions, the output vector are sent into the transformer model. The transformer use step attention measurements. It's how the model learn long-term dependence in the time zero data. The simple word, CNN focuses on local patterns, while transformer focuses on the long-term relationship. By combining CNN and transformer, the model can run more complete information and improve the power forecasting accuracy. The slide shows the actual operation interface of the monitoring system. The system provides several functions. First, users can enter the system through the web browser. Second, user can see real-time zero power generation data. 3. User can preview historical data. 4. User can download historical record as CSV file. These functions are useful for zero power management. Maintenance personnel can check the system stats remotely. The system also provides data for later analysis and model training. Overall, the monitoring system was successfully and provides simple and practical interface. This slide shows the forecasting results for the CN transformer model. First, the train and validation curve show the model performance during training. The loss and the MAE decreased during the training process. This means the model can learn from the data successfully. Next, the conversion between actual power generation and predicted value is showing. The actual power curve and the predicted curve is very close. This means the model can follow the real trend of photovoltaic power generation. During the daytime, zero power increases when sunlight becomes stronger than its degree when sunlight becomes weaker. The predicted curve can also reflect the rising and falling trends. This result shows that the CN transformer model can good forecasting ability. In conclusion, the study developed a zero photovoltaic power monitoring and forecasting system. The system integrates ability real-time monitoring and CN transformer forecasting model. For the monitoring part, ESP32, RS485, NBRD, and MQTT are used to collect and transmit real-time zero power data. For the forecasting part, CN is used to local vector instruction, and transformer is used for runtime time zero running. The results show that the system can monitor zero power generation in real time and predict photovoltaic power trends with good accuracy. Therefore, the process system can improve zero photovoltaic power management and predict accuracy. This is the end of my presentation. Thank you for your attention.
Okay, that's Mr. Xu's report. And is there any discussion about this report?
What are the architectural features of this hybrid module?
Its main feature of this hybrid model is that it combines the advantage of CN and transformer. CN focuses on local vector instruction, such as short-term change and zero power and wear data. Transformer focuses on long-term temporal dependence by use self-attention measurements. By combining them, the model can run both local panels and global time zero trends, so it can improve photovoltaic power forecasting accuracy.
Okay, that's Xu's report. And any question more?
What can we do with the forecasting result?
With the forecasting results, we can estimate future zero power generation in advance. It can help power detection, energy management, and maintenance handling. For example, if predict power is low, the system operator can prepare all energy source or adjust the power supply stage earlier.
Okay, Professor, he is.
Okay.
Please go to page 7.
Page 7? Yep.
Could you explain how to combine CN model and transformer model? So you're just using the CN model in the decoder part or encoder part?
Can I use the Chinese?
Okay.
Sorry. 我们的话是我们那个 CN 送进去的话是有那个一个矩阵的长度，我们就是训练完之后有做一个长度的切割，然后我们最后是先把它送到那个因为选手有 decoder 跟 encoder 那我们是先送进去 encoder，那同时的话我们就是我们这架构的话其实是我们这边其实有2个架，就是会有 encoder 跟 decoder。那其实我们的话是把那个我们这边那个调整完的全部都放到 encoder， 那我们的训练的其他资料我们会把它放到 decoder 这边。OK， 不好意思。
Okay, that's Mr. Xu's report.